Hi guys, today we're going to discuss the roots of quadratic equation are alpha and beta, where alpha plus beta equals to -5/2 and alpha cube plus beta cube equals to 115/8. So this question is taken from the past paper of FPM 4PM1 paper 2, and we will discuss 10A and 10B. So guys, this is 10A, shows that alpha beta equals to 4, and B form a quadratic equation with integer coefficient that has roots alpha squared plus 1 over beta and beta squared plus 1 over alpha. This question value 10 marks, so let's get started. If you need some more time to think or want to try on your own, please pause this video. Okay, let's get started. Okay guys, so we see here for A we have a alpha plus beta equals to -5/2 and alpha cube plus beta cube equals to 115/8. Now we'll try from here. So we know the expansion of a cubic. We will use this. So guys, we start from expansion of alpha plus beta cube. So we use Pascal triangle to get the coefficient 1, 3, 3, 1, and we start from alpha cube, then decreasing index, and then expand this with decreasing index of alpha. Then for beta we do increasing. So for beta it's beta 0, and then beta 1 and beta 2 and beta 3, and then we add the addition sign here. So the expansion of this will sum up to alpha cube plus 3 alpha square beta plus 3 alpha beta square plus beta cube. Now this is what we want, alpha cube and plus beta cube. Now we rearrange the equation, alpha cube and beta cube we put together, and 3 alpha square beta plus 3 alpha beta square here. Now we want to isolate this so we can get it the same here. So we move the rest here, these two, to the other side. So guys, we move the 3 alpha square plus beta plus 3 alpha beta square to the left here, so to the left side, and we have alpha cube plus beta cube. That's what we want here. So now we switch left and right hand side, and now we factorize this one, because these two has the common factor of 3 alpha and beta. We take that out. Now if we factor out 3 alpha beta, what will be left from this part is the minus plus alpha, and what will be left out after we factor out the 3 alpha beta is a beta. Alright, so that's the clue. So we have alpha plus beta is -5/2. You can insert in here, and we have this is 115/8. Now we can actually count that. Now by plug in the value of alpha plus beta and alpha cube plus beta cube, we will get the solution of what is alpha times beta. So we plug in this one, 115/8, and then for this one we have alpha plus beta is -5/2 cube, and minus 3 alpha beta, and then alpha plus beta again is -5/2. Now we rearrange the equation. So guys, we have 115/8 minus 5 cube is -125/2 cube is 8, and plus minus become positive here, and 3 times 5 is 15/2 alpha beta. Now time to isolate the alpha beta. So guys, we move -125 to the left, then become an addition. So we add this one, become 115 plus 125, it becomes 240/8 and equals to 15/2 alpha beta. Now we set alpha beta as our subject, So we have alpha beta equals to 240 over 8 divided by 15 over 2. Now this becomes a multiplication times 2 over 15, and we have to just simplify this now. So 2 and 8 become 4, and 240 and 4 is 60. So now 60 divided by 15, we will get a 4. So that is how we show that it is proved. So we got our answer that alpha beta equals to 4. That is 4. Okay. Okay, now we are in question 10b. Form a quadratic equation with integer coefficient that has roots alpha squared plus 1 over beta and beta squared plus 1 over alpha. So to make a quadratic equation, from the roots we have to get the sum of the product, sum and the product. So let's start with the sum here. So guys, we write the sum of the first and second root here, we add and then we rearrange the equation. We will have to equalize the denominator. So to equalize the denominator, this we times by alpha become alpha beta. This part we times by beta over beta. So beta over beta, will put the beta in here and this put bracket, and we now can combine the denominator, become alpha beta. Now expand here, so become alpha cube plus alpha plus this become beta cube plus beta. Now over alpha beta. So now we rearrange alpha and beta cube. So alpha cube. So we got here alpha cube plus beta cube is alpha plus beta. We rearrange over alpha beta. So we know all the value. Alpha beta is 4 and alpha plus beta is minus 5 over 2. Alpha cube plus beta cube is 115 over 8. So just plug in the number. So guys, we plug in the number. Alpha cube plus beta cube is 115 over 8. Alpha plus beta is minus 5 over 2. And alpha times beta is 4. We got from the previous calculation. Now we just have to count this with calculator. We get the answer. Calculate, we'll get 95 over 32. That is for the sum. Now count the product. So guys, we put the root side to side and we times, and now we expand here. So we will get the alpha square plus 1 times beta square plus 1 over alpha beta. Now we have to expand this to bracket. Now we expand here, we come alpha square beta square. This one become alpha square plus this become beta square, and the last become plus 1 over alpha beta. Now what we have to do is we have to just collect this one alpha beta, put in the bracket, and then this part is, we have to remember the algebraic identity, alpha plus beta square minus 2 alpha beta plus 1 over alpha beta. So now we see that we have alpha beta is there, alpha plus beta also is there, the value, and alpha times beta, and then alpha times beta. So we just plug in the number. So for your information, this one alpha square plus beta square, how do we change to this form is we have to remember the algebraic identity. Algebraic identity is alpha plus beta square. The expansion of the square is alpha square plus beta square plus 2 alpha beta. Now if we want to isolate the alpha plus beta square, so it will be alpha plus beta square minus 2 alpha beta. That will get alpha square plus beta square. So that's why we plug in to substitute alpha square plus beta square with this one. This left hand side is alpha plus beta square minus 2 alpha beta. Now what we have to do is we just plug in the numbers. So alpha times beta is 4 square plus alpha plus beta is minus 5 over 2 square minus 2 times 4 plus 1 over alpha times beta is 4. So count this all with calculator, we'll get the answer. Simplify 16, 4 6 16 minus 5 over 2 squared is 25 over 4, minus 2 times 4 is 8 plus 1 over 4. So we calculate this with calculator. So guys, we got 61 over 16. Now time to rearrange everything. So guys, now we have x square equals plus. Now to make the quadratic equation, we know that what we need is x squared plus negative of sum of roots and then plus product of roots. So let's assemble the quadratic equation. X squared plus negative of 95 over 32, that is the sum of the product that which have counted earlier. Now the product of the roots is 61 over 16. 61 over 16, this one has x plus 61 over 16 equals 0. Now we have to just cancel out the denominator. To get that done, we multiply the whole equation with 32 to cancel out the 32 and 16. So multiply by 32. So we times the 32 to each term here. So 32 times x squared will be 32x squared. Now 32 times minus 95 over 32, so this is cancelled out, so we get minus 95x. Now 32 times 61 over 16, we will have 2 left because 32 divided by 16 is 2, so plus 2 times 61 equals 0. So rearrange everything. 32x squared minus 95x plus 1 plus 122, 2 times 61 equals 0. So that is our final answer. This is our final answer, guys. Okay guys, today's discussion is conducted by Study with Tuition Online. We cater for all the subject and this program. Email us if you are interested to join with our online tuition. Subscribe and ring bell so you'll not miss any of our latest video as we keep updating daily, weekly, monthly. And check the link below down describe as there is free resources from grade 3 up to grade 12 and also calculus and for pre-course. Bye bye and see you for now. If you have any question, any difficult question, you can upload in Google Drive, send the link in comment section. We will see what we can do for you, and bye bye. And don't forget to give likes to the video, it will encourage us to make more video like this. Bye bye and God bless you.